Hello, so today we are doing this Leetcode challenge, part of Leetcode April 80 challenge. So the problem says that we get a binary search tree, we get the root of it, and we want to rearrange it in order where the leftmost node becomes the root of the tree, and every node should have no left child and only one right child. So if we take a look here, so if you go here, take a look. So what we are doing is that so 1 becomes the root, which is the leftmost child, and then its parent becomes its right child, the parent of that the right child, the left child becomes the right child, and then so you can see we are doing an in-order traversal, and then their parent becomes the right child, and so basically leftmost is the root, then its parent is the child, and then if there was another like right node here, let's say 0, then we will put it after it as well, right? 0 can be here because 2 it has to be bigger, but if there was another node here, then it will be after it, and then we'll go to the parent. So left node right, which is the in-order traversal. So that's the idea, and then we go to the right side, 6, and then we go to its. So sorry, first we would have went to the left child of 6, but since there is none, we go to 6. After that, the left child of the next one, the left child of its right child, and so 7, and then 8, and then 9. So this is the idea. So the first simplest solution we can do actually is just instead of doing is to just do an in-order traversal of the tree, right? Just do an in-order traversal of the tree, which means which will get us a sorted list. So it will get us 1, 2, 3, 4, 5, 6, 8, 7, 9, and then once we get that, just construct a tree where each node, where each value in the list becomes the right child of the previous value, right? So a very straightforward solution that we can do right away. It's not the most optimal, but it should be straightforward. So what do we need to do? We need to have our in-order function first. So we have node, and then we need to call in-order on the left side, in-order on the right side. Okay? And now we need to have the values in order, right? So we can just actually, instead of doing, okay, let me do it first with the values. So we need the values, right? So let's just assign them to self. We'll get rid of that later. And this would be just values, append node that value. So this is normal in order traversal. And if not node, we want to return nothing, just return, because we are assigning here. So we call in order with the root first. So this will give us the values in the right order, that in the right sorted order, left, node, right each time. Okay, so now that we have this, we need to just construct the list. So let's define a function that does that. And so that function will need the current index that we are looking at in the list, right? And for that function, we just need to, each time when we call it, we need to do I+1, right? Now, how do we set the node? Okay, so we need to call I+1, right? We also need to create the node with the value before calling the next. So the first element is the root, right? So node, we need to create our new node, and that node will have the value at that position, right? Because if we take a look here, in our first example, what we'll have is we'll have 1, 2, 3, 4, 5, 6. This will be the result of our 8, 9. This will be the result of our in-order traversal. So our values will be equal to this. And so what we do is we make this first the root, and then we set its right child to the tree that we get from this, which will have the root 2 as well, right? And so the right child is node.right is equal to this. And now we want to return the node each time. So when we are recursing here, we want to return the node to 1, to the node 1. And then at the end of the last call, the node would be 1, and we want to return that. And so we return node here. Now, what should be our base case? Of course, when we reach the end of the list, the end of values, right? And so we want to check if I is equal to the length of values, then we should be done. What do we want to return? When we are done, we should just return none, so that 9, which is the last node in the result, gets assigned the value null, right? Because it's the leaf node, and so we just want to return that here. Yeah, and so now here we need to call it. What's the first value for I? It's just 0. The first position is the root, right? And that's pretty much it. We want to return what we get from that. So let's run this. So this is self.values. Same thing here. If we wish, we could also pass it. So yeah, that would be cleaner. So let's pass it. And we need to pass it here as well. This is self.values. And okay, so that passes test cases. Let's submit. And that passes successfully. Cool. Okay, so now one optimization we can do here is this here with self.value is not nice, right? So what we can do is just return the list that we get from the left side and turn this into a list so we can add it. So this is just a list of the node value, so we can append it. So that would be just adding it like this, and then we want the right side, the list from the right side. And for each subtree, we return left, node, right as a list. And so here, when we reach the end, we want to return an empty list so that the concatenation and adding here works. And so we do this. And now our values are equal to this. And we pass it to our in-order traversal. Okay, so let's run this. This is no longer self-values. This is just values. Okay, and we can submit. And this passes test cases as well. Okay, so now the next optimization or the next thing we can improve here is that instead of creating this extra space, because this has all of an extra space because of the values. Okay, so instead of creating that, can we just do it while doing the in-order traversal, so that we don't have to we don't have to do 2 passes, and then also we don't have to create an extra space. So how can we do that? So first, I'll just separate these like this, and then put this back here. And now we need to do something with our node values, node.val. So first, we don't need this construct anymore. We can remove it, but first let's just comment it out. And now we don't need this. We need to still call in order, but we don't need to call construct. So what should we return? That's something we need to figure out here. So what we can do first is let's create a placeholder for our initial node. For our new, basically we'll create a new tree. We'll not do it in place. We'll create a new tree that gives us what we want here with this this format here. Okay. So So we need to create just some placeholder for it. So I'll create a sentinel just to make this easier for us. And it's a tree node with whatever value you want. And then at the end, we want to return sentinel.right. On the right side, we will set our tree. The other thing is I will have a current value that traverses, so that basically when we are, let's go back here, so that when we are here, we hold reference to current here. And this is so that we can set the rest of the tree as its right child. And as we move, when we move to the next node 3 here, we set that current there, right? So it moves the tree, and we will keep sentinel pointing to 1 so that we can return it at the end, right? Okay, so we will have current, which does the traversal. Initially, it's at sentinel, okay? And now we go here, and what do we want to do? We want the right side to be assigned, so self.current.right, we want that to be the node value. And we want to advance self-current so that it's pointing to the new right, so that the next one will assign it to the right side. And so we'll do self, we'll move current. So you can think of it as a linked list, because its format is like a linked list. We would have 1, 2, 3, 4, 5, 6. And so this would be current.right. And then we would move to the right. Okay? And this is exactly what we are doing here. So before, the value was then each time we add to the list node.val. And then after that, we go ahead here and make it the right side. But instead of doing this in 2 passes, we just, each time we make the right side the node value. So we can get rid of this. And now that should be pretty much it. We just need to, so we are already returning it here, so that should be good. Yeah, I think that's pretty much it, so let's run this. The only thing here is that we should no longer return a list. We are not returning anything anymore from in order, so let's remove this. And this says that, so the right side, this shouldn't be a node value. Each time we will be creating a new node. So this is tree node for node.val. We don't want to assign node because node has reference to the original list's left and right side. And that seems to work, so let's submit it. And that passes test cases as well. Yeah, so instead of doing it in those 2 passes, we can do it this way. Yeah, I think that's pretty much it for this problem. Thanks for watching, and see you in the next one. Bye.